Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about a graphical approach to solve quadratic inequalities. Let's start. A quadratic inequality is something like this. You've got a quadratic expression followed by a greater than 0 or a less than 0. Okay. Now, couple of things. If it's a greater than 0, it must be interpreted as positive. Okay. So sometimes when we see greater than 0, something like x greater than 0, it literally means x is positive. And whenever we have less than 0, it must be interpreted as negative. Okay. Negative if the quadratic expression is less than 0. Okay, that's the key thing to remember. Now, if that is our understanding that the quadratic expression is positive, then it all boils down to graphing this quadratic curve, the parabola. Okay, so if we can make a sketch of this parabola, of this quadratic curve, then just by looking at the graph, we can say where is it positive? And positive means above the x-axis. So that's the key point to remember, okay? Here's a key point to remember. Greater than 0 implies finding the values of x, finding the values in the domain where the graph, the parabola in this case, is above the x-axis. So keep that in mind, okay? So whenever you have greater than 0, you're trying to find the values of x, where the graph, the parabola, is above the x-axis. And wherever your quadratic is less than 0, whenever you have less than 0, that means we're trying to find the values of x where the graph, the parabola in this case, lies below the x-axis. Okay, in this particular video, we're going to consider two examples where you have greater than 0. In the next video, we'll take examples where you have less than 0. But the main thing is about sketching the graph, looking at the graph, and figuring out where is the graph above the x-axis and where is it below the x-axis. Cool, let's go for it. So what do we do in order to graph? Well, the first thing to do is to identify the factors of that quadratic expression on the left-hand side of that inequality. So you'll get something like x minus 2, x plus 1, and that's greater than 0, all right? So for those of you who haven't seen my video on writing down the factors under a minute, something like that, I'll link that video in the description box below. Go ahead and take a look at it, because identifying the factors of a quadratic expression, especially when you are solving such examples where you have to find the values of x for the inequality, it'll really be helpful if you know such handy tips, okay? So these are the two factors. And why are we finding the factors? It's so that it will help us identify where that quadratic curve cuts the x-axis. Those are the roots. Those are the x-intercepts, right? So let's draw the coordinate axis quickly. And here we go. That's my coordinate axis x and y. I'm going to label that x and y. And what do we have? We've got x-intercepts occurring at 2 and negative 1. So what I'm going to do is that if that's negative 1, that's going to be 1, that's going to be 2. And these are rather approximate, but this is just going to give us an idea, right? This is just to give us an idea. And all right, so 2 and negative 1 are going to be our points. So negative 1 and 2, those are going to be the x-intercepts, and the y-intercept is going to be negative 2. So if that's going to be a negative 1 out here, negative 2 is going to be our y-intercept. Okay, these are the points that the curve must pass through. And then the turning point, x-coordinate of the turning point is going to be negative b02a. That's a negative, that's 102, all right? So somewhere at half, x is equal to half, that's half. Somewhere there, the graph must turn around, okay? So we're just going to mark it out here somewhere, approximately, somewhere around here. Now, these are approximate measures. For those of you who haven't seen my video on, the vertex method where you can identify the vertex or the turning point, I'm going to link that entire playlist. Please go ahead and take a look at that, because those are handy tips if you were to solve this quadratic equation using a graphical method, okay? And it might seem a little blurry right now, but hear me out, okay? So what have we done? We've identified the x-intercepts. How did we do that? Well, we quickly factored that. The factors give us the x-intercepts. The second thing was I identified the y-intercept. The y-intercept is just that c, the constant term, and then the x-coordinate of the vertex, okay? So then we can draw the parabola identifying a, okay? That a, the leading coefficient is positive, a is 1, positive, which means it's going to be a U-shaped parabola. And then if you draw a parabola that goes through these points, okay, and turns around here, this is just going to be a rough figure. There you go. All right, so it goes from, okay, this way. So as x increases this way, as x values go, you have to look at the graph as it goes from left to right, right? As x goes from here to here, the graph gets sketched this way, okay? So it's coming down and turns around here. It's got to be symmetric. This is just a rough figure, okay? So as x goes from left to right, read the graph from left to right, the parabola goes this way. So now after you've sketched this is the main thing. It's a graphical approach. Like I said, you need to be able to sketch it, okay? If you can sketch it clearly, then your question is to find out where is this graph greater than 0. And what did we say? Greater than 0 implies where is the graph above the x-axis. So when you look at the graph, okay, there's a certain section, I'm going to color it differently. There's a certain section, this section, before that first intercept is above the x-axis. After that second intercept, okay, it's above the x-axis. So that is the portion of the quadratic we are looking for, okay? When is this graph above the x-axis? That's the portion. So when is it above? Well, before this intercept and after that intercept. Before this intercept and after this intercept, that graph, that parabola is going to be above the x-axis. How do we write it down? We say, well, when x is less than -1 or when x is greater than 2. Those are the values. Less than -1 means all values on the left-hand side of -1. Greater than 2 means all values on the right-hand side. So for those values of x, the graph is above the x-axis. And that is how you solve a quadratic inequality using the graphical approach. What did we do? We first factored it. We identified key parts of the graph, okay? A. Why do we need to know A? That will tell us what the shape of the quadratic is going to be. Is it going to be a U-shaped parabola or is it going to be an inverted U-shaped parabola? A being positive, U-shaped, A being negative, inverted U. Then we identified simple things like the y-intercept. Well, that constant term C gives us the y-intercept. And we also, this was not that important, but just, helpful to know where it's going to turn around. The main things are the x-intercepts. Once you've factored that and you've identified that, all that you have to do is that look at the graph and say, okay, where is it above the x-axis? If the question involves a quadratic greater than 0, that means you're trying to find the values of x where this graph is above the x-axis. Let's take one more example to illustrate this. Here, A is negative. I've deliberately chosen A as negative. So A is a -1. Negative means what? That shape is going to be an inverted U-shaped parabola, okay? Let's find the factors, okay? How do we do this? Okay, so if I bring a factor out of -1, that can be written as x squared minus 6x plus 8 greater than 0, all right? All I've done is that factored out that -1, that's still A, all right? So now we need to factor this term out here. This can be written as, this is a plus, so this should be a negative, and that's 4 and 2. Okay, this is a fast way of writing the factors. And like I said before, it'll really help if you know certain tricks, how to write down the factors of a quadratic, especially if you're using a graphical approach to solve these kind of inequalities. Why did we find these factors? Well, that is where we will get the x-intercepts. It's going to be an inverted parabola, and those are our x-intercepts. X equals 4 and x equals 2, all right? So let's draw that axis again. Where's that tool? Here we go. I'm going to draw the axis here. Can you see this? There you go. All right. And we want x equals 4 and x equals 2, correct? So this is approximately 1, 2, 3, and 4. Cool. And the y-intercept is going to be that constant term, right? The constant term was a -8. So -8 is somewhere here. -1, -2, and if I were to extend this y-axis somewhere here, remember this is just a graphical approach, so approximately you can make these things because you're just interested in finding the values of x where the quadratic is above the x-axis. So that's -8 because that's going to be our y-intercept. So that's a key point. And another key point are these intercepts. X is equal to 2 and x is equal to 4, okay? Now, we also need to know the coordinates of the turning point. And if you just estimate the x coordinate of the turning point, the vertex, that's good enough. And that's going to be -b, which is a -6/2a, which is going to be a -2, It's going to be 3. That's going to be the x coordinate of the turning point, and x equals 3 is bang in the middle here. So somewhere there, approximately, it's going to turn around. Why do we need to know all these things? Well, that gives us a rough idea of what the curve is going to be. So it's going to cut the x-axis at 2 and 4 and turning around somewhere at x equals 3. And the graph, there you go, it cuts at y is equal to negative 8. Can you see this graph of mine? Cool. Once you're able to sketch this, I think, this is a really handy tool to know how to sketch even without a graphing calculator. Then all that you're doing is that you're looking at the graph and saying, when is it above? Why are we asking that question? When is it above? Because that is what this question has to be interpreted as. This is a quadratic. Greater than 0 implies above the x-axis. So looking at the curve, that portion is above the x-axis. All this is below the x-axis, right? This is the x-axis here. Okay, this is the x-axis. That green portion is above. So what are the values of x? What are the values of x? And how did we read? Remember I said read from left to right. X values read from left to right. As we come from left to right, all these values are below. All these values are below. As we come from left to right, all these values of the graph, the quadratic graph, are they below the x-axis. And the moment it reaches that first intercept, which was x is equal to 2, the graph goes above the x-axis. And as it goes above the x-axis, it continues above the x-axis for values in between 2 and 4, which is the second intercept. And after that, the graph goes below the x-axis. So to answer the question, when is the graph above the x-axis? Well, that's for these values only, the values of x being greater than 2 and less than 4. So for those values of x alone, this quadratic is going to be above the x-axis. In the next video, we're going to talk about solving quadratic inequalities using the same graphical approach where that quadratic is less than 0. See you in that video.